buoyancy will be equal to W. It will not be sufficient to support W plus W. So what happens? Downward force becomes more and the buoyancy at draft D becomes less, fall short. And what happens? As a result, the vessel will sink. And the vessel sinks to a new water line, W1, L1, and to a new draft, D1. When the vessel sinks to this new draft, D1, again, the volume of buoyancy now provides sufficient buoyancy to support this new displacement of capital W plus small w. Why has the draft increased? The draft has increased because you are assuming that the water that found its way in the compartment is the water loaded on board the vessel. Have you understood what I said, beta? Yes or no?
Yes, yes.
Guys, any questions on whatever I have said all this while?
No, sir.
Okay. If you follow this process, which is absolutely fine, nothing wrong with this process, then you will be said to be following a method called as added weight method. Sometimes it comes in theory and it can be asked in orals also, guys. Okay. So if you are assuming that the water that has gone into the compartment is the weight added to my ship, thus increasing her displacement, then the method you are adopting is called as added weight method. And this method is no different from what you are already familiar with. It is like loading some weight or taking some ballast. This method is exactly the same. Whatever happens with loading will happen with this under this method. And we know what all happens with loading. What happens? First thing, the high draft, what all changes? High draft changes. Under added weight method, the high draft changes. Yes, yeah, it will change.
Yeah.
Displacement changes. Yes, it changes.
Changes.
All corresponding hydrostatic particulars also change. You can name them if you want to make your answer longer. All corresponding hydrostatic particulars in your MV Midship stability booklet, all these particulars will automatically change, because when your ship instead of 10,000 tons is now drawing 11,000 tons, you will pick up the particulars for 11,000 tons. Okay, so you will list all those if you want to list. They are what? They are TPC, MCTC, KB, LCB, LCF, KMT, KML, besides D and W. There are total 8 of them out there. So they all would undergo change under the added weight method. Also, what would happen is, since you have added the weight on the ship, it may not coincide with the original center of gravity of the ship. Therefore, in all probability, the G of the vessel of the ship is going to change. That means it may result into change of kg depending on vertical disturbance it causes. It may cause the change in the longitudinal center of gravity depending on longitudinal upsetting it causes, or it may cause a shift with respect to the center line, the transverse shift of G. Guys, all this you know happens when you load any weight on the ship. Anybody has any doubts on it? If you have understood this, then you have understood one method of handling damage stability, bilging. That is the added weight method. If you have any questions on added weight method, let me know. Is this well understood, guys?
Yes, sir.
Yes, sir.
Okay.
Yes.
No, why I'm asking you is if it comes in theory or there is an engagement during orals, then you should not be fumbling. You should be able to express yourself in your own words without messing it up technically. So this method is called as added weight method. Guys, what triggered the change here? The change was triggered, the draft increased from D to D1. It was triggered because the displacement changed. So please remember, in the added weight method, the trigger is the change in displacement. Is that clear, guys? Is that clear? In added weight method, the trigger for the change is the change in displacement. Do you all agree with me? Yes or no?
Yes, sir.
Okay. So one method done. Very good. What will happen? The water will first enter here, and as she sinks, the water will keep rising and the water will fill up to the final water line. This will happen in the bilged condition under the added weight method. If you want to take the screenshot of this page, you can take it, because once you look at it, probably you'll be able to recall what I have tried to explain. Can I go to the next slide then?
Yeah, okay.
Added weight method we have already done, guys. Okay, now I go to the next one. Now, we go back to the same diagram that I had drawn there. I have the ship, length L, breadth B. Okay. Floating at WL at draft D. Has an empty midship compartment of length L, small l, and breadth small b. Okay. This compartment gets bilged. Water. Now, before the compartment gets bilged, what happens? If the displacement of the vessel is W tons, let's say 10,000 tons, then what is the volume of buoyancy? Volume of buoyancy is V, which is good enough, that is L, B, D.
D, yes.
And that is what? It is sum total of V1, V2, and V3. This V will be sum total of V1 plus V2 plus V3. Yes or no, beta? Correct, guys?
Yes. Yes, sir.
Okay. Now, when the compartment gets bilged, then the water finds its way into this compartment. Okay, very good. In the earlier, W and V are in equilibrium before bilging. Why? Because volume of buoyancy V, which is sum total of V1, V2, V3, is providing sufficient buoyancy to support 10,000 tons of displacement. Now, what will happen when this compartment gets bilged? When this compartment gets bilged, this compartment up to this level first gets filled up with seawater first. Okay, that is not the final I'm saying. It gets filled up to seawater. Okay. Now, tell me, guys, if the water has come into the compartment, and if now the vessel rolls or vessel pitches, will this level inside the compartment remain same, or it will change with the rolling, pitching, and the movement of the vessel?
It will change with the rolling pitching.
It will change. Why? Because the level inside, okay. So what will happen? So the level inside has to be same as the draft outside, and the vessel rolls, pitches, the draft at that compartment location will change, causing the level to change. If the level is changing, what is happening then? If the level is rising in the compartment, that means more seawater is coming.
Yes.
If the level is dropping, that means some water has gone out to sea. That's how the level will change. What does it then mean? It means that the water inside the bilged compartment is freely communicating with the sea at its own will. You have no control over it. When it wants, it goes out. When it wants, it comes in. That's how the level fluctuates. That means the water in the bilged compartment is not under your control. And this water since it's not in your control, it is in freely communicating with the sea. So the other school of thought says that since this space which is filled up by the sea water, over which I do not have the control, this water does not belong to me. It belongs to sea. If you remember, guys, yesterday, we did a question about two pontoons, right? We did this question yesterday, and somebody raised this doubt then. He said, what about the water here? This water here is part of the sea. Yesterday, you all agreed to this, yes or no? Did you agree yesterday to this part?
Yes, sir.
Correct. Just to satisfy your anxiety and query, let me just say, if the damage is large enough and I remove this entire part of the keel, then does it become like the pontoon case? Will it become a pontoon case like thing? Yes or no? Then how will this become? This will become like this, na beta? If I remove this keel from entire damaged portion, then will the vessel's hull become like this? Yes or no? Like this it will become, yes or no? It will become like this, yes or no, beta? The deck here. If I remove this entire keel, will it become yes or no?
Yes.
And does it become like the pontoon then? This becomes C, this is C, this is C. Yes or no? Correct? So now what I'm saying is, whether this damage is at the keel or on the side below the waterline, it doesn't matter. Whether the damage is 1 square meter or the entire keel is removed, it does not matter. It does not matter. Question is, here also this water was freely communicating with the sea. Once this is bilged, this water is also freely communicating with the sea. So what is happening? The water is freely communicating with the sea. So this is my earlier condition, LBD. This is WL. This is L and B. And now we are saying this was V1, V2, and V3. Now we are saying this one is basically this water does not belong to me. In other words, what am I saying? This volume V3 does not belong to me anymore. Yes or no, beta? It has joined hands with the sea. It has changed the loyalty from the ship to sea. Why? Because now, because of this bilging, this water can go in whenever it wants. It can come out whenever it wants. Yes or no, beta?
Yes, sir. Sir, just last 2-3 minutes. Just only this one, because my internet was just.
Yeah. This was the only thing I said. This was the only thing I was repeating, beta. Guys, any questions? Do you agree with me? Guys, do you agree with me?
Yes, sir.
Anybody has any doubts or any disagreement on this? Please let me know. So, earlier, I had displacement of W. I had buoyancy B. They were both equal. And the volume of buoyancy that was providing the required buoyancy was sum total of V1, V2, and V3. Why? Because earlier, all these three volumes were part of the vessel. Now, what has happened? Under this new discussion that we've had, we are saying this volume, which is V3, is no more part of the ship because it has been occupied by the sea water, which is freely coming in and going out. And if this volume does not belong to me and this is already part of the sea, then it is not displacing seawater. And if it is not displacing seawater, that means V3 is not now contributing to buoyancy. V3 is not contributing to buoyancy. If V3 does not contribute to buoyancy and vessel continues to float at draft D, then what happens? Now the volume of buoyancy is reduced to V1 plus V2. And when I multiply it with the density of the seawater, this buoyancy will fall short of displacement. What will happen? The buoyancy will fall short of displacement. There is no change in the displacement. Why? Because I have not loaded anything. I have not discharged anything. But what has happened is, because some of the buoyancy which was earlier contributing to, some of the volume which was earlier contributing to buoyancy is now lost. And therefore, my buoyancy falls short of displacement. When buoyancy falls short of displacement, buoyancy acting upwards, displacement acting downwards, buoyancy falling short, that means displacement is relatively more, it will cause the vessel to sink. Why? Because as the vessel sinks, it will tend to regain more of buoyancy. And let us say, again at D1 draft, a water line of W1L1, the vessel strikes a new equilibrium. Now, as the vessel sinks, the water rises in the compartment to this level. So this part of the volume still does not provide buoyancy. But what has happened is, this is the extra volume which has gone down in underwater. These two volumes will provide the extra buoyancy. So here, what has, in both cases, guys, please remember, in added weight method and loss, okay. In this case, what has caused, what is the trigger? Trigger is the shortfall in buoyancy. And we say loss of buoyancy. You have lost V3, the buoyancy, and therefore the vessel has to sink to regain this lost buoyancy. If you go by this concept that bilging is leading to loss of some of my buoyancy, then this method is called as lost buoyancy method. If you say that bilging has caused a loss of buoyancy to me, then the method is called as the lost buoyancy. Guys, the effect is same. There is the imbalance between W and B. In the added weight method, the imbalance was caused by increase of W, causing the vessel to sink. In lost buoyancy method, again there is imbalance. Imbalance is caused because of loss of buoyancy. There is no change in displacement, but the buoyancy has reduced, and that causes the vessel to sink. In both cases, sinkage is taking place. In both cases, the vessel will settle at the same draft D1. But how it is being perceived is different in the two different scenarios. In one scenario, you are saying it was the increase in weight which led to increase in draft. In the second one, I'm saying it is the loss of buoyancy which has led to increase of draft. And the second method is called as lost buoyancy method. Guys, any questions on lost buoyancy method or added weight method?
Sir, am I audible?
Yeah.
Sir, what if the compartment was in an initial condition, if the compartment was completely filled, and then
that will deal with. Don't worry. We don't rush ahead of it. Okay, let's not have too many buts and ifs. I'm just asking you, beta, do you agree with this imbalance between W and B? In one, W was disturbed. In the second, B was disturbed. Effect is the same. Cause is the different in both the cases. That's what I'm trying to convey right now. Guys, is this point understood that I'm saying?
Which part? This above the red one.
Sorry? Say again. Say again, beta.
In this lost buoyancy method, you already deducted this compartment based displacement, because displacement is equal to the buoyancy.
See. I'll tell you, beta. I'll tell you. Which volume of the ship which is under the water will displace the water? The buoyancy, the volume which is intact. But when this compartment in the midship is bilged and seawater is filling into it, then it is not displacing seawater. No, it is allowing the seawater to fill in. Correct? Yes or no?
Yes, sir. Now it's contact with the seawater, so there is no.
No, and it is filling up with the seawater, so it is not displacing. It will displace seawater only if it was intact. Yes or no? Like if you take a mug, an empty mug, okay?
Yes, sir.
First you have its open end upwards, and you try to press it in a bucket of water. As you are pressing the mug with its mouth up, open end up, it is displacing water. But now put the mug in the opposite direction with the open mouth downwards. What is happening? As you are pressing the mug down, the mug is getting filled up. Yes or no? It is not displacing the water.
No, it will go down till it will fill up.
It will keep filling up with the water, right?
Yes, sir.
So that is the difference. So in the bilged case, it is like the mug being kept inverted, and now the water is filling up in the compartment and is not getting displaced. If the mug was upright, it was displacing the water. Why? Because the volume going into the water was intact. And when you put it upside down, it just goes into the water, because the water will keep filling up in that space and there is no displacement of the water which is actually taking place. Guys, please let me know if there is any more thought coming to your mind. Understood, beta? So, what have I done in this lost buoyancy method? We disown the water which gets into the bilged compartment. We say it doesn't belong to us. It does not belong to me. So now what are the changes that the lost buoyancy method will bring about? Guys, the draft has changed in lost buoyancy method. Yes, it changes. Yes. What are the things that will change? Yes, it changes. Only the cause is different. What does not change? If the weight, this water does not belong to me, it does not add to my weight. So the displacement of the vessel does not change. Some parameters will change. Which parameters will change? Of course, when you have this loss taking place, whatever parameters which depend only on draft, they will all undergo a change. In fact, all other parameters except W, they will change because there is a change in draft. Okay. So whatever is the effect of draft on hydrostatic particulars, they will undergo a change except the displacement. And one more thing which is most important. If the bilged water in the compartment has a free surface, if the bilged compartment in the bilged water in the compartment has a free surface, then under added weight method, since that water belongs to you, the free surface also belongs to you. Am I correct, beta? Under added weight method, since the bilged water belongs to you, then any free surface created in the bilged compartment will also belong to you and will add to your FSM. Yes or no? Correct? Correct, guys?
Yes.
But in lost buoyancy method, if the water does not belong to me, it belongs to sea. The sea outside has so much of free surface, it doesn't bother me. So that free surface then does not belong to me. So what is another big advantage of this lost buoyancy method is, one is displacement remains unchanged. And second, free FSM caused in bilged compartment does not add to ship's FSM, does not add to FSM of the vessel. Guys, these are two very big advantages. Rest everything is same. Hydrostatic particulars will get altered there also. Draft will get altered there also. Everything is same. But there are two major advantages when you use lost buoyancy method. Again, I'm not saying lost buoyancy method is better than added weight method. No, I never said so. Both methods are technically as good or as bad as they can be. Okay. The advantages of the lost buoyancy method are for its simplicity to use. It makes the use simpler because when your displacement does not change, your center of gravity does not change. And if center of gravity does not change, your kg does not change, your LCG does not change, your center COG with respect to center line does not change. And secondly, the free surface in the compartment, if created, will not add to your free surface under lost buoyancy method. So guys, if you have to write a short note on lost buoyancy method and added weight method, would you be able to write and close it out, or do you have any questions?
Yes, okay.
Give it a thought. Biggest advantages of lost buoyancy method are A, displacement does not change. If displacement does not change, its direct fallout is that the COG does not shift. COG does not shift, that means LCG, KG, and with respect to center line locations remain same. And free surface, if created in the bilged compartment, does not add to the vessel's free surface because that water under lost buoyancy method does not belong to the ship. Is that clear, beta?
Yes.
Guys, any questions before we go on to learning the calculation part? And whatever other doubts are, whether it had liquid, it did not have liquid, it has solid, those will be automatically covered as we take steps forward. This is just to introduce what actually happens when there is a bilging which takes place, and then what else happens, we can keep adding and learning more and more as we go forward.
तो बेसिकली सर लॉस्ट बुoyancy मेथड में हम यही मतलब रहे हैं कि हमारा उसके साथ कोई रिलेशन नहीं, वो कंपार्टमेंट हुआ, उसके साथ जस्ट मेरा ड्राफ्ट इंक्रीज हुआ, दैट्स इट, उसके बाद मुझे और कुछ लेना नहीं है, दैट्स राइट.
हाँ, और बाकी जो लेना होगा we'll see in the further calculations, but yes, what you're saying is by and large the fact is that volume does not belong to me, that seawater does not belong to me, I've lost it to sea. That's why it's called lost buoyancy, because you've lost that volume to sea, right, Vite?
Yes, right.
Okay, so that is the lost buoyancy method. Now we will basically go on. So what will be following by and large will be the lost buoyancy method for the reasons advantages that I just told you. Guys, give me a minute. Give me a minute. I'll just mute myself.
गाइस, ये नेवा की थ्योरी के लिए व्हाट आर द गुड नोट्स?
सतीश.
कैप्टन सतीश भाई.
ओके. भाई किसी के पास हो तो
क्या बोलते हैं, मैं क्या बोल रहा था यार, ये ना थोड़ा अभी लगातार क्लासेस चल रही है, तो बीच में सर को बोले कि एक दिन दे देना थोड़ा बीच से बैकअप जो हो रहा है वो कंप्लीट करने के लिए, फिर सैटरडे या संडे सबको मतलब लगातार करते रहना है, क्योंकि 27 तक लगातार है. पीछे का बैग रह जा रहा है, कुछ मतलब समझ नहीं, कुछ करना होता है ना एक्सरसाइज, तो अगर
भाई-
सब लोग अग्री करें तो बोल के
हाँ।
कर लेते हैं।
क्लास के बाद ना बीच में एक बार आपस में डिस्कस कर लिया करो, बीच में अगर सर को बोल दोगे तो ये सिलेबस कवर नहीं होगा, बहुत लंबा है।
एक दिन की छुट्टी
वो
ले
तो
लेंगे,
है।
अपना कवर हो जाएगा ये मोमेंट ऑफ इनर्शिया।
वही एक दिन के बस, या तो सैटरडे संडे को ना
यार ये वाला
ये मोमेंट ऑफ इनर्शिया और ये बिल्डिंग
सिलेबस बहुत ज्यादा है, लास्ट मोमेंट में पैनिक हो जाएंगे, कंटिन्यू रहना।
भाई लास्ट टाइम पे फिर पीडीएफ भेजेंगे सर, जैसे सर बोल रहे थे, फिर वो देखते रहना, जैसे सीएल के क्वेश्चंस देख रहे वैसे देखने पड़ेंगे, वो अभी समझ लो काम आएंगे ये डिस्कस करने के। बड़े अच्छा टाइम है, क्लासेस खत्म होते हैं, एग्जाम 2-3 दिन के अंदर रिवीजन करके फटाक से एग्जाम दे देंगे।
Yeah, sorry guys, sorry. Okay, any questions while I was on mute? I was not here listening to you. Any questions? None. Okay. Now, first thing is basically, as I said, because of the convenience, we will be using the lost buoyancy method by and large. Okay. So we'll be closing all our calculations using lost buoyancy method, which is a preferred method for the simplicity that it brings to the working. That's all. That's the only reason. Otherwise, as far as results are concerned, they are both technically at the same level. Okay. Now, the first thing we have to learn is the draft increase from D to D1, and that is called sinkage. So first we have to understand and learn that. That will be the first step of every Bilging question, beta. Today we'll be talking in details, but when it comes to execution, you will not be talking in detail. You will be just executing in one step and finishing it off. Okay. Now, guys, I'll be asking you questions. Please freely participate. The more you participate, more I'll be able to understand whether you have the gaps or not. One thing I always recommend is standardize the notation, because we'll be making the expressions in the notations and then putting the values at the last step. Okay. What I prefer is that we use the length of the ship by capital L every time. We represent the breadth of the ship by capital B every time. We represent the length of the bilged compartment by small l every time. We represent the breadth of the small compartment by B. If there is a dB or something, we'll represent by height small h. The intact water line that we will draw will represent by WL, and the intact draft will always represent by small d. Every question will keep following the same. Okay. Now this midship compartment gets bilged. Okay. And this causes the vessel to sink to a new water line W1L1, and this new draft we will always call as D1, and it is this thing which is called as sinkage beta. Have you understood beta?
Yes, sir.
Okay. So now I will just use the red marker to mark the boundaries of the volume of the buoyancy in the intact condition. When the vessel was intact, this was the volume which was providing the buoyancy. Yes or no, beta? V1, V2 and V3 were providing the buoyancy. Correct, beta? Yes or no? So the total buoyancy, this is only for explanation. The buoyancy of the vessel is V1 plus V2 plus V3. Okay? Now, this compartment, midship compartment gets bilged. When this midship compartment bilged, bilged, sea water gets into this compartment. Okay. And it is free to come out also. So this point, now look at the diagram, and please use the notations that I have marked. Use capital L, small l, so specify which notation are you talking about. Look at the diagram and tell me what is the buoyancy that was earlier being used and now lost. What represents the lost buoyancy here?
V3.
What do I multiply to get the lost buoyancy?
V3 sir, lost
V3 is okay, but what do I multiply to get V3, bete?
LB उसका जो छोटा LB और DS.
Okay, so does everybody agree that L into B, small l into small b into D is the lost buoyancy? Correct, beta?
Yes.
Yes, sir.
Okay. Now, what happens is this causes the vessel to sink. So, first I shade the buoyancy that is lost. Do you all agree I have shaded the right buoyancy that was lost? Yes or no?
Yes.
The volume above WL in the intact condition was all reserve buoyancy. What I am talking about is that in the intact condition, this volume of the vessel was the reserve buoyancy. Do you agree with me, beta? This was the reserve buoyancy. Yes or no?
Yes, sir.
Yes, sir.
Now what happens as the vessel sinks? The water will rise up to this level as the draft outside. Yes or no?
Yes, sir.
Okay. Now I'm going to mark what is the new volume that has additionally got immersed. The volume that has got additionally immersed is okay, let me change the marker. The additional volume that has gone under the water because of the sinkage is A, this one, 2, this one, and 3, this one. These 3 volumes have gone under the water. At WL, they were above the water line. At W1, L1, they are below the water line. Do you agree with me, beta?
Yes, sir.
Yes or no? Correct? Let us say I represent them by small v1, small v2, and small v3. Now, out of v1, v2, v3, in the bilged condition, are all these 3 contributing to buoyancy, or any one of them is not contributing to buoyancy in the bilged condition? Small v1, small v2, and small v3.
So small V3 is not contributing.
Small v3 is not contributing to buoyancy is the answer. Does everybody agree or anybody has a doubt? Okay. But v3 was not contributing in the intact condition also. It's not contributing in the bilged condition also. Fine, fantastic. So, what is the buoyancy regained? What represents the buoyancy regained as per the markings in the diagram? V1, small v1, and small v2. This is the buoyancy you have regained. Yes or no, beta?
Yes.
Yes.
Correct? And how much buoyancy would you regain? Same as you have lost, because the law of flotation cannot be violated. You sank because the law of flotation was violated. You come to new equilibrium when the law of flotation is complied with. So do you agree with me that lost buoyancy and regained buoyancy have to be same? Yes or no?
Yes, sir.
Do you agree with me?
Yes.
Now, look at the diagram and tell me, upper diagram. Okay, now, I will first introduce you 3 terms. Guys, if you look at the water plane at the W1, L1 water line, this water line, water plane at this water line. Firstly, what will be the shape of the water plane at this water line? Better tell me. We'll discuss the water plane in detail.
Rectangular.
Rectangle, very good. Rectangle, very good. This will be the water plane. It's a whole water plane. This length will be L, capital B will be the breadth. But when you cut the ship in the bilged condition, what will happen? Here you will see the sea water. Yes or no? Here you will see the sea water in way of the V3. Yes or no?
Yes, sir.
Correct? Does this water belong to me? Does this water belong to me?
No.
No.
If this water does not belong to me, then that means this area also does not belong to me, because you remember that's how we defined the water plane area. We said wherever you can't see the sea water, when you look from top to the area which displaces the sea water is the water plane area. But when I see from here, what do I find? That in middle, this certain area is occupied by sea, and under lost buoyancy method, that water belongs to sea. Yes or no? Yes or no, guys?
Yes, sir.
Yes.
So now I will introduce three terms before I proceed further. One I am saying is whole water plane. When I'm talking of water plane, our focus should be on this diagram of the water plane drawn down below it. From this diagram, what is the whole water plane? The whole water plane is the complete water plane L into B. Agreed?
Yes, sir.
So this whole water plane is before bilging, no, sir? Before bilging.
No,
this
I'm introducing some terms, beta.
Okay.
So you agree this is the whole water plane? Yes or no?
Yes, sir.
Okay.
Yes, sir.
Out of this, some water plane is lost. Now, lost water plane, the length of the lost water plane will be L, breadth will be small b, it will be small l into b. Yes or no?
Yes.
And from the whole, whatever is lost, we shall call it as intact water plane, which in this case will be LB minus LB. Do you agree with me, beta? Yes or no?
Intact means whatever remaining from the lost.
Beta, earlier when we were talking about, you remember when we were doing the BML BMT formula, first I wrote I is the moment of inertia of the water plane, but then eventually what did I tell you? Let's insert the word intact against it, right?
Yes, sir.
Why? Because if the whole is intact, then whole is intact. If something is lost, then what we are going to deal with is the intact water plane. So intact water plane means the water plane of my vessel. In the before bilging, the whole water plane was intact. Let me put it that way. Before bilging, the whole water plane was intact. After bilging, the intact water plane is reduced to capital L into capital B minus small l into small b. Is it now clear or there is still some doubt?
Yes, clear.
Tell me, beta. Somebody was asking about whole water plane. Is that clear, beta?
Yes, sir, clear.
Whole water plane is same, but whole is not intact after bilging. Before bilging, it was fully intact, right?
Yes,
Okay, sir, clear.
Okay. Now, so please remember these terms. Now, next is, let's look at this upper diagram, the side elevation. Let's see what is V1 equal to. If this is sinkage, let us say this is sinkage, then V1 will be equal to what? The area, the volume will be like this. Yes or no, beta? This volume will be like this, correct?
Yes, sir.
Yes or no?
Yes, sir.
And this volume will be like this.
Yes.
Guys, do you agree with me?
Yes, sir.
Yes, sir.
These are the additional, or these volumes represent the regained buoyancy. Now, one way of getting the regained buoyancy is you get this water plane area A1, multiply why? Because this is the water plane area. Multiply by the sinkage and you'll get volume V1. Yes or no, beta? Correct? One second. Let me just make the water. Let me just change it a little bit. I think just make same thing I'll do, but I'll make it right beneath it. Instead of the diagram being, this is the side elevation, length, breadth, draft D, midship compartment LB, WL, lost buoyancy, goes to a new water line, W1 L1, represented the draft as D1. Now below this I am making the water plane in the bilged condition at W1 L1. And below this bulkhead, you will have this bulkhead. Below this bulkhead, you will see this bulkhead. And in bilged condition, you will find that there is sea water here. Whole water plane is L meters by B meters. lost water plane is small l by small b. Now I think you can correlate the diagrams better, right, beta? Now, this volume is additionally filled up with water and does not contribute to regained buoyancy. We already had the discussion. So the regained buoyancy is small v1 and small v2. Up to this place we had discussed before I cleared everything. Yes or no, beta? Correct, beta?
Yes.
Yes or no? Now you see, let me come on the screen. Let me come on the screen and let me take a book. Let me unshare the screen. Okay. Let me pick up a book. I'm sure I'm visible to all of you. Yes or no? Okay. Okay, here is a book. This represents the buoyancy regained. This represents the volume of the book, represents the buoyancy regained. Okay, I'm not talking about the total buoyancy, it's the buoyancy regained. Correct, beta? If the whole water plane was intact, then the buoyancy regained will be length into breadth into sinkage. Yes or no? Correct? Yes or no, beta? Guys, do you agree?
Yes, sir.
Yes, sir.
Okay. Now this time the whole water plane is intact. Okay. Now in this whole water plane, I cut out a square, maybe from full breadth or some breadth, doesn't make a difference. I cut out a square of small l by small b and cut it through all the pages and remove that. That means what have I done? I have made a hole in the book, a square or a rectangular hole of dimensions small l and small b. Have you agreed? Do you agree with me?
Yes, sir.
Yes, sir.
When I remove that part, do I lost some volume of the book? Yes or no? If I cut out
Yes,
some
sir.
part and remove that entire block, have I lost some volume? Yes or no?
Yes, sir. We
Yes,
lost.
sir.
Will the volume of the book reduce? Yes or no?
Yes.
Yes, sir.
Yes, sir.
So now if I have to calculate the volume of the book after that thing has been removed, one way is I add volume on one side, volume on the other side, volume here, volume there, whatever is left. That is one way of doing it. The second way of doing the same thing can be, I take one page, the area, and from the whole area, if I remove how much area has been cut off, that means I am left with intact area. I'm removing the word water plane right now. So I calculate the intact area of the page, and then intact area of the page, if I multiply by the height of the book, will I get the remaining volume of the book? Yes or no?
Yes, sir.
Yes, sir.
Do you all agree, or is there a doubt?
Yes, sir. Copy, sir.
I said that, let me just take a page which I can tear off. Okay. Okay. Now this full page is intact right now, beta. Now from this page, I remove something. And the breadth can be full, breadth can be less, doesn't make a difference. So B can be anything. What have I done? I have removed some area of the book page, correct, beta?
Yes, sir.
And
Yes,
if I
sir.
remove this from all the pages, these are two pages from which I removed the identical area. Now what am I left with? This remaining area I am calling as intact area of the page, because the other remaining area is lost. What have I lost? I have lost this part of the area. The remaining area is intact. Now, if I calculate this intact area, and I multiply with the height of the book, that will give me the volume of the book after the portion has been removed. Yes or no, beta?
Yes, sir.
Yes, sir.
Sure?
Yes, sir.
Sure, guys? Okay. Okay, so let me just put off the camera and go back. It's visible, right?
Yes, sir.
So exactly like the book. Book was also cuboidal. In my case, my vessel is box shaped. Now, what I was talking about was, I was talking of this as the book. Let me just mark what I was calling as a book here, there. If this is understood, then the job is done actually. This is the book you were seeing from the side. Yes or no, beta? Correct? Correct, beta?
Yes, sir. Yes,
This
sir.
is the whole page of the book, the water plane area.
Okay, sir.
Then from this page, this much area is cut out. That means this much area is cut out. Then what happens is, my intact area is A1 plus A2, yes or no, which is equal to
Yes.
whole minus lost, yes or no?
Yes, sir.
Correct. And this intact area, now let me make it a 3D thing. If I have this as the sinkage, then will this give me this entire volume will be lost in our case, and I'll be left with V1 and V2. Yes or no, beta? Does the 3 degree view give you some idea now about the volume that we are talking about?
Yes, sir. मतलब जो हमारा व्हील जो है उसका हमने वॉल्यूम डिडक्ट कर दिया.
What I am saying is, like the intact page, if I have the intact area of the water plane, because my water plane represents the page of the book, and if I multiply by the sinkage, will I get the regained buoyancy? Yes or no, beta?
Yes, sir.
Guys, tell me.
Yes, sir.
Yes,
Yes,
sir.
sir.
Will my regained buoyancy be equal to intact area of the water plane multiplied by sinkage? Yes or no? Please, if you are not convinced, let me know.
No, sir. So, I don't understand.
What did you say? You have understood or not understood, beta? Sorry, I missed
Not
out.
understood. Not understood.
Okay. I was explaining you something about the book, right?
Yes, sir.
Did you understand the book or no?
Yes, sir. Books I understood. कि
Okay.
आपने उस एरिया
This was the book, right, beta? The book had this much of thickness, little bit of thickness, and this was the book that I had shown to you, right? Right, guys, this was the book. Am I right?
Yes, sir.
Okay. In this book had this length L, breadth B, and sinkage as height. What is the volume of the whole book, beta?
Length, breadth into sinkage.
Very good. Now, if I remove this much of the book, I cut out this much of book of length L, breadth B. Is the volume of the book reduced?
Yes, sir.
Okay, then what will you do? If I want to ask you what is the remaining volume, then you will say, sir, either add V1 and V2. Perfect. But don't you think the easier way would be, first, when you said the volume of the whole book, you said was L into B into sinkage. What was L into B? That was the area of the whole page. Am I right?
Yes, sir.
Now, from the area of the whole page, if I remove this area which has been cut out, that means LB minus LB, then I'll be remaining with these two intact areas. Yes or no?
Yes, sir.
And if I multiply this with sinkage, will I get the intact volume? Yes or no in the 3D? Now, is it clear? Or still doubt?
Yes. Yes, sir.
No, no. Review it. Tell me. If you have not understood,
Yes,
I'll
sir.
try to change.
Yes, sir. Understood.
Pakka?
Yes, sir.
Guys, anybody else who has a problem, let me know. Is that clear, guys? What I've said? Okay. तुम मेरी ना इंजीनियरिंग ड्राइंग इंप्रूव करा दोगे, बाकी तो कुछ नहीं है. ठीक है, कोई बात नहीं. Okay, now I make the diagram clearly and now I'll go systematically, guys. Okay. The ship has length L, breadth B, floating in intact condition at waterline WL. Every time the same thing we have to repeat. At D, has a midship compartment, small L and small b. It gets bilged. This is the lost buoyancy. Causes the vessel to sink to a new water line W1 L1 with a new draft being D1. This being the sinkage. Okay. And the water will rise here, of course, but the lost buoyancy will remain LBD only. Okay. What is the water plane area in the bilged condition? The water plane. Now I'm drawing the water plane area right below this. We'll be making these two diagrams, one above the other like this. The whole water plane is like the whole book, L into B. The lost water plane is this one, small l into small b. And what I'm left with is the intact water plane. Now, looking at the upper diagram, you told me before I cleared the screen that lost buoyancy is LBD. I don't think that should have any problem. That should be a problem. Yes or no?
No.
Regain buoyancy based on my discussion a while back in the 3D diagram of the book. If you don't agree, let me know. It is equal to intact water plane into sinkage. Yes or no, beta? This is what we try to understand with the book. Am I right? Correct? Intact area of the page, whatever was torn out, that area was removed from the total, and you got the remaining area of the page multiplied by the height of the book, gave you the remaining volume. Yes or no?
Yes, sir.
Yes, sir.
बोलो भाई.
Yes.
फटाफट बोलो. अगर नहीं समझ में आया तो फिर बोलो. I'll come on the camera again. Beta, compared to the book had the full volume. Okay. And each page was full. Page represents water plane area. Volume of the book is the volume, buoyancy regained. Okay. If the full area was intact, then the full area multiplied by sinkage would have been the volume of the book or the buoyancy regained. If I remove some part of the book, cut out the some part, then what happens? What is the remaining area of the page? The remaining area of the page is the total area minus whatever has been cut out. Do you agree? Yes or no?
Yes,
Yes, sir.
No, wait. Sorry. Guys, this was the whole page. From this part has been cut out, and this part has been cut out from all the pages of the book. So what is the remaining area? The remaining area is the total page area minus the area that has been cut out. Do you agree?
Yes, sir.
In our discussion, the whole area of the page is the complete area of the page is the whole water plane. Okay. The cutout area is the lost water plane. Is that understood better?
Yes, sir.
Clear? The full area is the whole water plane. Cutout area is the lost water plane in our discussion. But right now in this page, you can say full area minus the cutout area. Correct, bete? Yes or no? Bolo bhai, fatafat.
Yes, sir.
Yes, sir.
And now I have more pages. All pages are cut out the same way. If all these pages are put together one after the other, will it form the volume of the book? Yes or no? Will it form the volume of the book? Yes or no? If I put all the pages together.
Yes, sir. Yes, sir.
And if I hold the book like this now, what will be the volume of the book left? Volume of the book left will be the area of the page that is left multiplied by the height of the book. Yes or no, beta?
Yes, sir.
And height of the book in our context is the sinkage. Understood? Clear हुआ नहीं हुआ बताओ भाई या और एक बुक को एक्चुअली काटूं. I can cut a book actually.
Okay.
Doubt होएगा तो बेटा बाद में problem होती है. Then we'll pick up speed, no issues. What I'm trying to say is regained buoyancy will be the intact water plane. That means the remaining area of the page multiplied by the thickness of the book, which is sinkage in this case. Correct, bete? Understood? Okay. And what is intact water plane in this case? Intact water plane is, look at the lower diagram. This is the water plane diagram. Intact water plane is whole water plane minus lost water plane. Do you agree with me?
Yes.
Correct, beta?
Yes, but sir, पहले सर आपने sinkage को multiply किया, but we don't know the sinkage ना, so before that
So
we need to.
we don't know the sinkage. It's okay. Sinkage is what we are trying to find, na?
Yes, sir.
Sinkage is what we are trying to find. Don't worry. That's what we are trying to find, na, beta?
Okay.
Okay. So as per law of flotation, both these buoyancies have to be same. Whatever you lose, you have to regain that much. So as per law of flotation, lost buoyancy and regained buoyancy have to be same. What is your regained buoyancy? It's intact water plane multiplied by sinkage. What is your lost buoyancy? It is whatever it be. Let's say, I'll just write lost buoyancy. From here, what do we get? Sinkage is equal to lost buoyancy divided by intact water plane. Do you agree with this now?
Yes, sir.
This will be the formula to calculate sinkage. This will be the formula to calculate sinkage. Somebody was asking about sinkage. This entire explanation is to get sinkage, beta. We wanted to come to this formula that lost buoyancy is equal divided by intact water plane gives you sinkage, is what I was wanting to come to.
Okay.
Okay. Please remember, this will be the first step of every question. And now, if you have understood this well, then there will be no problems at all. I'll give you a break, but not right now. Let me take a question and then think of giving you a break. Guys, everything, all issues will be resolved. We'll keep increasing the complexity level. So your focus should be only on the scope that is covered in a question. Okay, don't allow your mind to wander. What will happen if this was to be done? What will happen if this was not done? There is a reason why these questions are sequenced so that everything gets covered in a manner so that every time you have to little bit to learn and not a complete thing. So we will go in a stepped manner, okay? So now in these questions, now pay attention, guys. If you have not understood whatever has been said up till now, it will not make much difference to the numericals. Pay attention to every word from here on. In these questions, the first and foremost is the diagram. There will be two diagrams to be made, one above the other, one below the other. One will be the side elevation, other will be the water plane at the bilged condition. I'll be speaking everything very slowly, executing, asking you if you have any problems, and then I'll complete. A box-shaped vessel is 100 meters long, 20 meters wide. We'll use the notation that we have been using. So first I'll do part A. Part A you have already done, you already know it actually. Length of the vessel, 100 meters. Breadth of the vessel, capital B, 20 meters. Always use the notations. Floating in an intact condition at waterline WL, a draft of 6 meters if I'm not mistaken here. As a midship compartment of length 30 meters, breadth 20 meters, that means from side to side. Calculate the GM of the vessel in the intact condition. So let's deal with the intact condition first. We all know that GM will be equal to AM minus KG because there is no mention of FSM. Okay. What is KM equal to? AB plus BM minus KG. It's a box-shaped vessel, intact condition. I'm sure KB needs no discussion. KB will be draft by 2 equal to 3 meters. Am I right, guys? box-shaped vessel. We are talking about the
Yes,
first
sir.
part in the intact condition before bilging, which you already know. Actually, I should not be doing it, but I just want to take you through again. Then we have to calculate the BM. For BM, I have to visualize the water plane at WL. The water plane at WL will be a rectangle of length L, breadth B. Then I have to visualize its center of flotation, which will be here. For BMT, I need to draw a fore and aft axis. This is application of moment of inertia, guys. This is center line. Now, BM will be equal to ICL of intact water plane. Now, mind the full is intact, it's fine. Upon V.
Yes, sir.
What is the whole water plane is intact and it's a standard axis, so LB cube by 12.
Yes.
Volume of buoyancy comes from the upper diagram. It will be LBD. LLB. So it is B square by 12D. And B is 20 square by 12D. You will get some, D is 6, sorry, my mistake. 6 is D. How much you get, beta? Can you pick up the calculator? Sorry?
5.55.
5.55? 0. 555 or what, beta? They speak the full. Pura bol do, beta, please.
Sir, say 5.55.
Okay, 550. Okay, meters. So now we are good to get the GM in the intact condition. KB 3 meters, BM 5.550 minus kg of 7.5, and this gives GM. This is the answer to the first part of the question. I don't think this has any doubt. This you already know. You've mastered over last 4 days. Correct, guys?
Yes, sir.
We come to the second part of the question, and I'll go slow here. We are now going to do this part. This is the vessel, and I'll keep telling you the sequence also. First, draw the side elevation. Length 100 meters, breadth 20 meters, floating at an even keel draft of 6 meters. D is equal to 6. Midship compartment, length 30 meters, breadth 20 meters is bilged. It will. So then now I'm shading the lost buoyancy. My lost buoyancy would be this when it gets bilged. This will cause the vessel to sink to a new water line W1L1, and she will be floating at a new draft of D1. Water will rise here. I mean, so don't miss out these things because otherwise they will lead to confusion later on. That means this volume is occupied by seawater. Because it is occupied by seawater, that means this area is lost. This will keep reminding you. Now below this, right below this, I will draw the water plane at W1L1. Water plane at what? Final water line. At the final water line, the water plane will be like this. Water plane will be a rectangle of length 100 meters, breadth 20 meters. I'll see the bulkheads in the plan view like this. And in this part, I will find the seawater being here. Length 30 meters, breadth 20 meters. And this water plane will be lost. Guys, any doubt on the two diagrams that I have made? They hold the key to the entire solution. Are the two diagrams clear?
Yes, sir, clear.
Okay, now we first find sinkage. Formula for sinkage we just did. Lost buoyancy, and slowly we'll stop writing this also upon intact water plane.
Yeah, it's good.
Guys, the lost buoyancy will come from the side elevation diagram. It's already shaded. Intact water plane will come from the lower diagram. Okay, it will come from the water plane diagram. Okay, I'm sure you'll agree. Look at the upper diagram, see the lost buoyancy shaded portion. It's LBD. Next is come to the lower diagram for intact water plane. The best way will, somebody can say I'll add 2 intact areas. That is not a user friendly way. It is technically fine. Best way will be from the whole area, you remove the lost area. That means capital LB minus small lb. Do you agree with what I have written in the notational form, beta?
Yes, sir.
Yes, sir.
Guys, any doubt?
No, sir.
This has come from this diagram. This has come from this diagram. Please be very careful from where these things are coming. These diagrams are guiding you. Now you just need to put the values. You know all the values. Small l is 30. Small b is 20. D is 6.
Point.
Yeah, okay. I'll just put the values for the sake of good order. Then we'll start cutting you short. How much it is coming?
0.4286.
428 meters. Is that correct, guys? Can you confirm?
Oh, no.
I don't think it has to be much more, beta. I don't think it's 0.428.
Yes, sir. Clear, sir. Clear.
Is it 0.428 only?
2.
Check again.
Myself.
Sir, 2.57.
2.57.
2.571.
2.571 meters, beta. Understood, guys?
Yeah.
Once I get sinkage, I am good to get D1. D1 will be equal to 6 plus 2.571 equals to 8.571 meters. And now on the diagram, upper diagram, we'll put the value of D1. D1 is 8.571 meters. Always follow these practices, beta. Okay, now we have to get the GM in the bilge condition. The formula for GM is the same, guys. GM will be equal to KB plus BM minus KG. Okay. Now, see, in this case, KB will be D1 by 2, but every case it will not be. I'll tell you what you need to check. But let me first tell you why it is D1 by 2. Look at the upper diagram. In the bilged condition, this is one volume of buoyancy. And this is the other volume of buoyancy, because everything in between is not contributing to buoyancy in the bilged condition. Do you agree with me, beta?
Yes.
Yes or no?
Yes.
These two red bound volumes are the volumes of buoyancy in the bilged condition. Yes or no, guys?
Yes, sir.
Well, where will be the center of buoyancy of the left one? It will be here. Where will be the center of buoyancy of the right one? Because they are both cuboidal. Where will be the combined geometric center? It will be here. So it will be KB by 2. But if you ever have any doubt, so your KB, I'm telling you, will be half of 8.571, which will be equal to, but I'll tell you, we'll calculate it also, don't worry. 4.286 meters, that is KB. But we also should know how to calculate KB by moments, beta. How to calculate KB by moments. And now pay attention, this is the most important step of this particular topic. How to calculate KB by moments. And if you understand that, then your half the job will be done now after the diagrams. Diagram was the first important thing, and now the next is this one. Guys, what is B? B is the geometric center of the volume of buoyancy. Correct? Yes or no? Correct?
Yes, sir.
So if I take the one way of doing, you see, In phase 1, when we had two volumes of buoyancy, V1 here, V2 here, one way of doing was take the vertical moment of V1 about keel, to add to that add the vertical moment of V2 about keel. That becomes the total vertical moment of volume of buoyancy, divide by V1 plus V2. That is one way of doing, and absolutely in order. Since we will have more complexities coming in the questions that follow, for us, what we will practice is, instead of adding V1 and V2 moments, we will say, what is the vertical moment of the underwater volume? Now I'm using some terms, guys. One term I'm using is underwater volume. Underwater volume need not be volume of buoyancy. Why? Because the vessel is bilged. Second, underwater volume. Second is not volume not contributing to buoyancy. Okay. Now look at the upper diagram. Look at the upper diagram and pay attention, and now speak up. In the bilged condition and notational form, don't give me 100 into this, into that. I don't want numbers. In the notational form, use capital and small wherever need be. In the notational form, what is the underwater volume up to W1L1? What represents the underwater volume up to W1L1 in the notational form, guys? Tell me.
Capital L into capital B into D1.
Okay, everybody agrees that up to W1L1, the underwater volume is represented by capital L into capital B into D1. Does everybody agree? Yes or no?
Yes, sir. Yes, sir.
Does everybody agree?
Yes, sir.
Okay, very good.
Yes, sir.
So all of you agree that up to W1L1, the underwater volume is capital L into capital B into D1. Okay. What will be the distance of geometric center of this underwater volume from keel in the notational form? It's a box-shaped vessel, remember that. What will be the distance of the geometric center of this underwater volume from keel?
D1 by 2.
D1 by 2 is one answer. How many of you are in agreement, or does anybody want to differ?
Half of you.
Okay, so let me just use the colors and for the sake of thing. See, guys, when I'm saying the underwater volume up to W1L1, I'm talking of this full volume. Agreed? And when I'm talking about distance of its geometric center from keel, it will be somewhere here, which will be D1 by 2. Do you agree with me? Yes or no?
Yes, sir.
So now, if I ask you, what is the vertical moment of underwater volume up to W1L1? What will you multiply with what? Vertical moment of underwater volume up to W1L1.
Underwater volume multiplied
You
by...
will first identify the underwater volume, which you said capital L into capital B into into D1. And next you will multiply by liver, and liver you told me is D1 by 2. Yes or no?
Yes, sir.
Correct, guys?
Yes, sir.
So what are we saying? Pay attention to the expression I'm using. Vertical moment of underwater volume up to W1L1. And my eye goes on the diagram on top. First, I identify the underwater volume. The underwater volume is LBD1. For vertical moment, I multiply the liver from keel, which is D1 by 2. Is it the vertical moment of underwater volume up to W1L1? Yes or no, guys?
Yes, sir.
Yes, sir.
Okay, now pay attention to another answer Try to answer, no problem. From this underwater volume, look at the diagram. From this underwater volume, I'm again saying from this underwater volume, what represents the volume that does not contribute to buoyancy? Look at the diagram and tell me in the notational form.
A small L into a small B into D1.
Into D1. Does everybody agree or anybody wants to remain stuck at D?
Sir, LVD, sir, not D1.
I repeat my statement, listen to it again and then speak better. From this underwater volume, which one? LBD1 up to this W1L1, this green volume. From this green volume that is bound by the green box, which volume does not contribute to buoyancy?
Yeah, L, B, D1. The small L, the small B is D1.
Tell me, from this entire green box,
small b and D1.
LB, D1,
Yes,
right? And somebody
Yes,
who
sir.
said D, does it now make, this is the volume in the underwater, this volume is under the water but not contributing to buoyancy. Do you agree with me now, beta?
Yes, sir. Yes, sir.
Yes.
No, somebody who said D, is that clear now, beta? The person who said D,
Yes,
beta?
sir.
Okay. So,
Yes, sir.
so now I'm writing the vertical moment of underwater volume and frail not contributing to buoyancy. So first I identify that volume. That volume is LBD1. Look at the diagram. What will be the vertical lever for this volume?
Into D1 by 2.
Into D1 by 2. Okay. So from this beta, from this vertical moment of the full underwater volume, if I remove this which is not contributing to buoyancy, if I subtract, what will I be left with? Will I be left with vertical moment of volume of buoyancy? Yes or no?
Yes, sir.
From the total, the vertical moment of the total underwater volume, underwater volume now comprises of two parts. One, which is either contributing to buoyancy. Second, which is not contributing to buoyancy. So from the total moment, I have removed the moment of the volume that was not contributing to buoyancy. So then what are you left with? You are left with vertical moment of volume of buoyancy, yes or no?
It is also we can say it is intact moment.
Yeah.
We don't use the word intact. You can it is intact only because if the volume is intact, then only it will contribute to buoyancy. What that way you're right, but we don't use that way the terminology, beta. Okay.
Okay.
Guys, do you
Yes,
agree
sir.
that whatever is written
Yes,
is
sir.
the
Yes, sir.
volume of it is the vertical moment of volume of buoyancy, correct?
Yes.
And if I divide the volume of buoyancy, the moment of volume of buoyancy with the volume of buoyancy, moment with volume, what will I get? If the vertical moment of the ship's weights is divided by the ship's displacement, what do you get? kg.
KB.
Yes or no?
K.
kg, correct? If you take the vertical moments of volume of buoyancy and you divide by volume of buoyancy, you will get the kb of the vessel. Yes or no, beta? Simpson's rules,
Yes, sir.
if you recall.
Yes, sir. The final KV we will get this.
You will get the kb in the Bilged condition, right?
Yes, sir. The Bilged
Okay.
condition.
So in this case, tell me what will be the volume of buoyancy? If I divide this with, see, I can get it without calculation in this case because it's a simpler case, but we should know how to calculate if the need arises. If
So
I
divided by-
divide this with LBD1, which is this one volume, minus LBD1,
D.
this
Yes,
should
sir.
give me the kb in the Bilged condition. Yes or no?
Yes, sir. Right.
Guys, please try to understand. I'll give you enough practice. Don't worry. Don't get panic if there is a problem. If you are not in agreement, just clear the concept. That's all. I'll redo this question. I'll clear out everything. I'll speak everything again and redo it. So let me know if there's any doubt until now. Okay, guys, what have I done? From the total vertical moment of the underwater volume, I removed the vertical moment of the volume that was not part of the buoyancy. The difference left me with the vertical moment of volume of buoyancy, and I divide this with volume of buoyancy. It will give me the KB in the bilged condition, which I need for my purpose. Yes or no, beta?
Yes, sir.
Yes, sir.
Now, one more simplification can be done here. Which method are we following?
Lost buoyancy method.
Lost buoyancy method. Okay, very good. In the intact condition, what was the volume of buoyancy? Volume of buoyancy in intact condition. Look at the diagram and tell me.
LB into
LBD, right?
Yes.
Yes, sir.
Correct?
Yes.
And volume of buoyancy will change only if the displacement is changed or the density of the water is changed. Correct, beta?
Mhm.
Volume of buoyancy will change
Yes, sir.
only when the displacement is changed or the density in which the vessel is floating is changed. Yes or no?
Yes.
Correct?
Yes, sir.
Yes, sir.
So in my case, the vessel's displacement has not changed under lost buoyancy method. So if you calculate this denominator, this will come same as LBD. So instead of going through a lengthier process, I can just replace it by LBD. If you make it LBD1 minus small LBD1, that is also fine, but it will unnecessarily involve extra calculation. Correct, Vete?
Okay.
So we can just replace the denominator and make it LBD. Why? Because we are following lost buoyancy method. Have you understood?
Yes, sir.
Okay, I'll clear
Yes, sir.
this and I'll redo everything from scratch. And you guys can interject at any time, but I'll be speaking as if I am doing in the exam. I'm doing part 2 of the question. First, I will make the side elevation of the vessel. Step 1, side elevation. Use the notational forms and put the dimensions on the question. WL is the intact water line. D is 6 meters. Has a midship compartment. Length 30 meters. Breadth 20 meters. It's empty. And this compartment gets bilged. When this compartment gets bilged, this buoyancy is lost under the lost buoyancy method. I shade the lost buoyancy. This causes the vessel to sink to a new water line W1 L1, and this takes the vessel to a new draft D1. As the vessel sinks, this compartment gets filled up with water up to this water line. Okay. Now I make the water plane area at water draft W1 L1. Water plane area at W1 L1 is like this. The whole water plane is a rectangle of length capital L, breadth capital B. Then I'll be able to see these bulkheads in the plan view. The length of the compartment will be 30 meters, breadth will be 20 meters. Because of this water which I have dotted, water filled up here, I'll be able to see the sea water here under lost buoyancy. That water does not belong to the vessel, belongs to sea. Therefore, this area does not belong to the vessel. This is the lost water plane. Having done this and marked everything on the diagram, guys, just one confirmation. Up to this point, anybody has any doubts?
No, sir. Okay.
No, sir.
Very good. So all this has to be done. Whatever I'm doing, this is what I'm expecting you to do, beta. Don't try to cut short. Okay, now then, first we find out sinkage, and I'm talking to myself. I'll not write even the formula now. Sinkage. I tell myself lost buoyancy. Where do I take my eyes? I take my eyes to the upper diagram, the elevation. I look at what I have shaded as the lost buoyancy. It's LBD divided by intact water plane, whole minus lost. I look at the lower diagram, water plane diagram. The whole water plane is L into B. The lost water plane is L into B. I put the values here, and in one line, I complete the sinkage part. I don't allow it to fill up half the page. It was 5 point. How much you said, beta? So, how much was sinkage for this case?
2.571.
2.571. Okay. This gives me D1 equal to 6 plus 2.571, 8.571, and I put the D here, 8.571 meters. All good up to this point, guys? All good?
Yes, sir. Yeah.
Okay, now we go to AB. Now, let me calculate by moments. I'll tell you the shortcut. In this case, it is not required to be calculated, but I'll still calculate. KB in the bilged condition, KB final. Vertical moment of vertical moment of underwater volume up to W1 L1. Vertical moment of underwater volume up to W1 L1, and then I look at the upper diagram to figure out what is the underwater volume up to W1 L1. That is LBD1. I look at the lever for this one and multiply with the lever D1 by 2. This is the vertical moment of the underwater volume up to W1 L1. From there, I subtract the vertical moment of volume that is under the water, but not contributing to buoyancy, not coming to my rescue. And I look at the diagram again. The volume that is under the water and not contributing to buoyancy is small l, small b, D1. I look at its distance of its geometric center, the lever, D1 by 2. This leaves me with vertical moment of volume of buoyancy. This divided by volume of buoyancy will give me the AB. Since I am using lost buoyancy method, my volume of buoyancy will not change unless displacement changes. So what was the volume of buoyancy in the intact condition? It will remain same. Why? Because whatever you lost, you regained that much. So total volume of buoyancy has remained the same. So instead of going in a roundabout manner, this becomes LBD. In the next step, I put the values and then I pick up the calculator. On the run, I calculate and close it out. 100 into 20 into D1 is, write down like this. Don't waste your time in calculating the by 2 and all that. Write like this. Close it out in one go when you pick up the calculator. Don't unnecessarily (100 into 20 into 6). Please calculate and give me the KB final. The answer will be half of that. I can write down the answer myself. (4.286 meters). Please calculate and satisfy yourself, because wherever the moments are to be used going forward, then you should be able to calculate it, because there will be requirement of this process. And I want to address it in the first place itself.
Sir, I want to ask one question, sir.
Yeah.
Sir, I've already understood everything, but this the divided by length into breadth into this draft, the olden draft. Why you have taken this olden draft? This one I have not understood.
As per you, what should have been taken? You tell me. Okay. As per principle of moments, as per you, it should have been LBD1 minus capital L, capital B into D1 minus small l, small b into D1. Correct, Bete?
Correct, sir.
You do that, it will give you the same value. Why? Because what is the denominator? Denominator is the volume of buoyancy. What is the numerator? It's after subtracting, after the full numerator now is the vertical moment of volume of buoyancy. Yes or no?
Yes, sir.
Numerator is the vertical moment of volume of buoyancy. Agreed?
Yes, sir.
It has to be divided by what? Volume of buoyancy. Correct?
Yes. Yes, sir.
Volume of buoyancy will change if the displacement changes. Yes, or no?
Sir. Yes, sir.
We are following loss buoyancy method.
Yes, sir.
So it will not change, it will remain LBD. But if you want to make it capital L into capital B into D1 minus small l into small b into D1, you will get the same answer.
Okay, sir.
You'll get the same answer.
So
because
I can go with that
whatever
method.
you lost, you regained that much, no, bete? So total volume of buoyancy has remained unchanged. Is that clear now?
Okay, sir.
What is the KB you are getting? Is my answer correct, beta? Is it half of D1?
Yes, sir.
So in this question, we could have saved this working. We could have saved this working. But if the need be, and wherever, if you have any doubt ever, should it be D1 by 2 or not, please use moments and calculate. Okay, just a doubt whether it is D1 by 2 or not should not make you assume anything and mess up your question. What this principle of moments will always be correct. If it is D1 by 2, it will give you D1 by 2. If it's not D1 by 2, it will not give you D1 by 2. So why worry about it? Okay. When will it be D1 by 2? I'll address that condition later. Let me continue now with PM. So one of the two things we have got, KB we have got. Now we have to get the BM. Now let me write the formula for BM, if you remember. BM, when I say it means BMT. I said I of what? Intact water plane. I'm writing in detail for the first time. You don't have to write that much. About 4.5 taxes to COF. Do you agree this was the formula taught to you, beta, when we did the formula from BM? Yes or no?
Yes, sir.
Divided by V. What was V there? Go back to the formula if need be. What was V in the formula?
LBD1, sir.
Array, what was V? What is express? What is V? What do you call V?
Underwater volume.
Sir, intact volume.
Underwater.
Intact volume.
Underwater volume. Go back and see.
Sir, volume at the displacement.
Volume of intact volume.
It was the volume of displacement, I said, and I also said volume of displacement and volume of buoyancy are same terms. Yes or no? You remember
Yes,
that? Volume of displacement. Okay, it
Yes,
was
sir.
volume of displacement. It was not intact volume, underwater volume. Why are you adding? Yeah, I don't know whether you've written the formula or not. Suddenly you start changing the track, you know. V is the volume of displacement is what was taught there, right? Okay. Look at the lower diagram. Now, whatever I'm going to do on the diagram is not required to be done by you. Okay. This area has 3 portions, 1, 2, and 3. Out of 3, I'm sure all of you agree that only 1 and 2 are intact. 3 is lost. Yes or no? Am I right, guys?
Yes, sir.
What will be the
Yes,
center
sir.
of flotation? Center of flotation will be the geometric center of areas 1 and 2. Why? Because center of flotation is the geometric center of intact water plane. And intact water plane is 1 and 2. Where do you think will be the geometric center of intact water plane in this diagram? Yesterday we did a question of 2
Somewhere
circles of a raft. We
In the
did
third.
2 circles of raft. Yes or no?
Yes, in the third water plane area, the third area.
Okay, you're right, beta.
Middle.
Iska center of flotation will be here. Center of flotation of this one would be here. And since both areas are same, so the resultant center of flotation would be here. Yes or no? Am I right?
Yes. Yes, sir.
F is the center of flotation. It is not the geometric center of the whole water plane. It is the geometric center of intact water plane. Don't tomorrow tell me you marked it here as a L by B center. No, I'm not marking it as a center of L by B. I am marking it as a geometric center of the intact water planes. Is that clear, beta? Correct, guys?
Yes, sir.
And
Yes, sir.
then I have to do what? I have to draw 4.5 axis through it for BM. This happens to be center line. So my formula for BM, this was only for you to remind the formula. This is not I'm using. This you can disregard. BM will be equal to, now I'm writing with respect to my diagram, ICL of the intact water plane divided by volume of displacement. Do you agree?
Yes, sir.
Correct. Now intact water planes are 1 and 2. So one way is you add the moment of inertia of 1 and 2, the moment of inertia of 2, and you'll get the numerator. But again, we'll not use the addition method. We'll say ICL of the whole water plane. And from here, I'll remove the ICL of the lost water plane. Understood, guys? And then I'll be left with the ICL of the intact water plane. Yes or no? Do you agree with me, guys?
Yes, sir.
From the ICL of this full area, if I remove the moment of inertia of this lost one, will I be left with the moment of inertia of the intact one only? Yes or no?
Yes.
Yes, sir.
Divided by volume of displacement. Now I'll put in the notational form, then I'll put the values and you'll calculate. Look at the diagram. In the notational form, tell me what will be the moment of inertia, ICL of the whole water plane.
The capital L, capital B cube by 12.
LB cube by 12, okay. LB cube by 12. What will be the ICL of the lost water plane?
Small L
Small
into
L,
small
small
b
b cube by 12.
cube by 12.
Guys, what is the volume of displacement of the vessel? Under lost buoyancy method, I have given you the hint. Under lost buoyancy method, what is the volume of displacement of the ship in notational form?
LB, capital L, capital B, and D.
Guys, it is the same thing as volume of buoyancy. Yes or no? LBD. Volume of displacement. That means the volume that is being displaced to provide the buoyancy, right? Okay. Guys, has the displacement changed under lost buoyancy method? So if the displacement does not change, why should volume of displacement change? Correct?
Yes.
Am I right?
Yes.
So it will remain LBD instead of going in circles. Now I just put the values 100 into 20 cube by 12 minus 30 into 20 cube by 12 upon 100 into 20 into 6, and you will calculate the BM of the vessel. Now you'll pick up the calculator and just do it on the run. No more further simplification. That's why I'm saying use the notations first. Simplify or break the formula in the notational form. Okay, you can calculate the BM, and if anybody has any doubt, you can ask me.
3.889.
Okay, so to 3.889, okay. 3.889, okay. 889 meters, okay. Now we are good to get the GM. GM will be equal to KB. KB we got was 4.286. BM is 3.889. How much will be the kg under lost buoyancy method, guys?
7.5, sir, same, it will not change.
7.5, and this will give you the answer. If you have not made any mistake, it should give you 0.675 meters.
Yes, sir, correct answer. Same.
Okay. Now you have to review this entire process and let me know wherever you have doubts as to why something has been done, or if you have not understood what has been done. Next question that we do after the class, I would like your full participation wherever I put questions, because clarity on this one will help you. Okay, guys, now one more thing now, before I give you a small break of 5 minutes. When is it that KB will be D1 by 2? So that I can avoid the calculations. Guys, in the bilged condition, in the diagram above, from keel to W1L1, if you visualize the water plane in the bilged condition, from keel to W1L1, is it going to be the same as we have drawn here, or is it going to change anywhere?
Same.
It is going to be. Okay, so that is the prerequisite. If the water plane area in the bilged condition is identical, that means wherever it is intact, wherever it is bilged, lost, whatever it is, lost, intact, it is identical, exactly identical from keel to the final water line. In that case, your KB will be D1 by 2, because the volume is made of water plane areas. Like in case of book, when we had removed something from in between, the height of the geometric center will be still half the height. So you can visualize the water plane area from keel to water line, W1L1, and see if the water plane area at half a meter draft, 1 meter draft, 4 meter draft, 7 meter draft up to the W1L1 is same, then the KB will be D1 by 2 and you don't have to calculate that. You can just put a line and say that as the water plane area in the bilged condition from keel to W1L1 is same, KB shall be D1 by 2, and you can just get the answer straight away. Is that okay, beta?
सर यू मीन सर अगर जहाँ वाटर लेवल तक अगर इंटेक्ट एरिया है, अगर
इंटेक्ट नहीं बोला मैंने, आइडेंटिकल बोला है.
सो आइडेंटिकल, अगर उससे पहले ही कोई बाढ़ है या कुछ भी है,
मैं जब आएगा तो मेरे को नहीं पता. I don't answer like this. In this question, is it same? In this question, do you agree it is same?
Yes, sir.
Yes, sir.
So when it does not become same, you only will be able to see it, and if you're not able to see it, then let me know. Okay, because otherwise we'll get digressed to some other discussion. People, unless there is a complete diagram, it will lead to a lot of other issues. So in this case, if you want to calculate by moments, it's your choice. Nobody is stopping you from doing that. But if you are smart, you can save time. Okay, guys, the time is 11:32. I have to do many questions actually. Okay, 5 minutes break, 11:37, not even 11:40, 11:37, okay? Okay, बच्चों आ जाओ वापस. Let's get back, guys, so that we can use the time.
Okay, sir.
Okay, आ जाओ फटाफट. The bus is leaving. Okay. Read the question. Is the part one of the question same as earlier, or there is any change? Please tell me. If it is same, we'll skip it. If there's a change.
The height of the midship compartment is there.
No, I'm asking part A of the question.
Part A is same, sir.
Part A is same, sir.
In the intact condition, is there any change in the length, breadth, draft, anything? Yeah. dimensions of the ship. So part A, the answer will be same. Yes or no? So we can skip the part 1. Yes or no, beta? This answer is same as the previous question, right? Correct, guys?
Yes, sir. Yes, sir.
So now I'm taking the second part of it, okay? And I'll be asking questions in between. A box-shaped vessel, 100 meter long by 20 meters, same length, 100 meters, breadth, 20 meters, floating at a draft of 6 meters, WL, has a midship compartment, L 30 meters, breadth 20 meters, has a dB of empty dB of height 2 meters, H 2 meters. As I said, height of the dB will represent by 2 this. Okay. Calculate the GM after the dB is bilged, guys. So in this case, the bilging will be contained in the forward direction by the forward bulkhead. After direction, it will be contained by the after bulkhead. And its vertical extent will be contained by the tank top. Do you agree with me, guys? Yes or no?
Yes, sir.
So that means the lost buoyancy will be restricted up to this height. Am I right? Class, do you
Yes,
agree
sir.
with me?
Right, sir.
Yes, sir.
This will cause the vessel to sink to a new draft W1. D1, sorry, W1, L1 waterline and D1 is the draft. Now, guys, pay attention to what I'm saying. I want to draw the water plane area at W1, L1. So if I cut the ship at W1, L1 and have a bird's eye view from top, would the full water plane be intact or would there be a loss of water plane? Please visualize, don't say just for the sake of saying it. Satisfy yourself and then speak.
Fully intact, sir.
Fully intact.
Yes, you'll see these bulkheads, but you will not see any seawater here. Why? Because
yes,
this
correct.
tank top would contain the seawater. Yes or no?
Yes.
Yes, sir.
Why? Because I'm drawing this water plane. We don't write it actually. Water plane at W1, L1. Agreed, guys? The length of the water plane will be L. Full thing will be intact at W1, L1. Yes or no? Does everybody agree?
Yes, sir.
Yes, sir.
I just take 5 seconds or 10 seconds for people to grasp and revert if they have a doubt. All good, guys?
Yes, sir.
Okay. So now, if you want to lead, don't speak and disturb others. Calculate sinkage. First, write in the notational form, calculate the sinkage. Lost buoyancy from the upper diagram, intact water plane from the lower diagram. Calculate the sinkage. I'm just writing without speaking anything so that if anybody has a doubt, you'll be able to ask better.
0.6, sir. 0.6.
Yes. Guys, anybody who does not agree that D1 will be 6.600 meters, you can get back to me. I'll be happy to answer. Everybody is good with it, guys? 0.6. Lost buoyancy in the numerator, LBH. Intact water plane in the low denominator, L into B, and gives us 0.6, so that D1 becomes 6.6. Everybody's good with it?
Yes, sir.
Okay. Before the break, I gave you a condition to determine whether KB will be D1 by 2 or not. Please visualize the water plane area right from keel to W1, L1 and see if it is same through and through or there is a difference, change taking place.
There's a change taking place, sir.
Then
Okay. Where is the change taking place?
In the side view.
After
DB. See, below the tank top, up to 2 meters, there will be a loss of water plane, right?
Yes, sir.
if you visualize the water plane at 1 meter draft, there will be a loss of water plane. Yes or no?
Yes, sir.
Correct? Guys, do you all agree that the water
Yes,
plane area
yes.
up to tank top, there will be loss of water plane? Above the tank top, it becomes intact, fully intact.
Loss is only up to 2 meter only, water plane area.
Yes, so there is so that means, in other words, yes, what we are saying is that water plane area does not remain same from keel to W1 L1 in the bilged condition. Yes or no?
Yes, sir.
Guys, above the 2 meters, it is the way it is drawn here. From below 2 meters, the water plane will be like this. Yes or no?
Yes, sir.
Below 2 meters, the water plane will be as it was in the previous question, right? Correct?
Yes.
If you visualize the water plane here, bete, there will be a loss of water plane. Na? Yes or no? You will be able to see the sea water here. Yes or no?
Yes, sir.
Is that clear to everybody now? Guys,
Yes, sir,
speak
clear.
if there is any doubt so that I can continue then. So in this case, KB will not be D1 by 2. It has to be calculated by principle of moments. It has to be calculated by principle of moments. Okay. Okay. Now, please tell me in notational form. When I say vertical moment of underwater volume up to W1 L1, it has two parts. First, identify the relevant volume, then identify the lever. So what is the underwater volume up to W1 L1? How much is it?
L into B into D1.
D1. Okay, guys. Second step, please identify its vertical lever.
D1 by
What will be
2,
the
sir.
D1 by 2? Okay. From this, I want to subtract the vertical moment of volume that is under the water but not contributing to buoyancy. Look at the upper diagram. What is the volume that is under the water but not contributing to buoyancy? Identify the volume first.
So small L, small B into H.
B into H.
H. Is this the volume which is underwater and not contributing to buoyancy, guys?
Yes, sir.
What will be its lever?
1, sir.
H by
1.
H by 2. Don't say 1, H by 2, right?
H by 2, yes.
Divided by volume of buoyancy. What do I write for volume of buoyancy in the notational form, guys?
LB D1 minus
LBD. Loss buoyancy method. Why you want to go in circles? Volume of displacement, volume of buoyancy will not change under loss buoyancy method. Yes or no? Yes or no, guys?
Yes.
This will be equal to 100 into 20 into D1 is 6.6 into 6.6 by 2 minus 30 into 20 into 2 into 1 divided by 100 into 20 into 6. Get KB and you will find that it is not 3.3. It is different from 3.3.
$3.53.
3.530 is it? Okay.
Yeah.
Okay. Guys, any questions up to KB now calculation? We have called twice using vertical moments. I hope that should be clear now. And you have to just complete them in one line like this, talking to yourself. You can't keep explaining everything every time. Guys, can I go to BM if it's done so far? Understood? Okay.
Yes, sir.
Let's go to the water plane area at W1, L1. It's fully intact. So where will be the center of flotation? Here. What will be the 4.5 axis center line? I'm sure you'll agree. BM in the bilged condition, BM final will be ICL of intact water plane upon V. Fortunately, the full water plane is intact. So it will be LB cubed by 12. And volume of displacement, lost buoyancy method. So LBD B square upon 12D, which is equal to 100 square upon 12 into D is 6. How much is the BM we are getting, guys?
So it will be 20 square, no?
Sorry, my mistake. Sorry, I stand corrected. B square is 20. Sorry, my mistake. Okay. Yeah, how much it comes to? Sorry.
$5.556.
Same as last time. Okay, very good. Intact condition. 5.556. kg remains unchanged under lost buoyancy method, 7.5. How much is the GM you get? The answer should be 1.586 meters. I hope the things are falling in place now gradually, beta.
Yes, sir.
Okay. It will fall in place, don't worry. So these are not difficult ones. They are reasonably okay. So what do you see here? Here the GM is increased. Before bilging it was 1.055. Now it is 1.586. So please always don't think that bilging will always lead to compromise on GM. No. Situation like this, when it is contained by a tank top or something, the GM can actually increase. Whereas the previous one, the GM had reduced, here the GM has increased. Guys, 15 seconds on this slide more for me to stay and then go to the next one if you do not have any doubts. If you have any doubts, please let me know. Okay, we go to the next question then. Guys, the two questions that we have done until now have been done with compartments being empty before bilging. The DB was empty, the cargo space was empty. Okay. Now we'll bring in if the cargo space or if the compartment contains solid cargo or anything which is solid out there. We are not still dealing with the liquid, so don't get confused. Now what happens if suppose in a cargo space there is cargo, solid cargo inside the tank, in the compartment. Now what will happen? The cargo will occupy some volume. Cargo is not freely going to sea and coming back into the ship. It's not communicating with the sea. Only the water is communicating with the sea. So if the cargo is occupying some space, volume, then what will happen? The volume available for the sea water to enter will reduce. Yes or no? Correct, Peter? Correct?
Yes, sir.
And the cargo, since it is secured to the vessel, cargo will remain part of the ship because it's still tied to your ship. It's not going in and out to the sea out. You still have control over it. So if the compartment is not empty, and has some solid cargo or solid equipment or whatever, then that will reduce the ingress of water. Now, we are going to do our questions based on certain inherent assumptions, because if we do not have inherent assumptions, then we'll have to have complete details of a case. So our generic calculations will be based on certain inherent assumptions. Inherent assumptions for solving the bilging compartment carrying solid cargo are: number one, the cargo is filled in the complete compartment. That means from side to side, forward to aft, bottom to top, the compartment is completely full of the cargo. Otherwise, somebody has to say up to what height the cargo is given, which is not usually given to us. So we shall assume that the cargo is completely filling the compartment. 2, cargo is homogeneously distributed in the compartment. Homogeneously means it's same, uniformly distributed and not non-uniform. If it is heterogeneous, then details have to be known. That you have lead pellets here, you have some other cargo here, then it has to be given, which details will not be given. So we will assume cargo is homogeneously distributed. 3, cargo after bilging does not shift, it remains secured to the ship. No loss or shifting of the cargo has happened due to bilging. That is again an inherent assumption when we discuss these type of problems. Cargo does not absorb water, because if it absorbs water, then the situation is going to be different. So again, those are the assumptions. Have you understood the inherent assumptions? When we'll be solving these questions, you should not have doubts. Sir, what happens if the cargo was to absorb water? Sir, what happens if the lashing breaks and cargo is lost to sea? If you say, no, the cargo was not filled up fully, how do we know it was filled up fully? So such questions shall be solved on these assumptions. Am I clear, beta? Is that clear, guys?
Yes, sir.
Okay, so there should not be any confusion as to why we are assuming that it is full, why we are not saying it's half full, why the cargo cannot be lost to sea. If it is lost to sea, then you have to give me what cargo has been lost to sea by. Okay. Then we come to permeability, represented by small p. Permeability is the term which will tell us how much volume is free for the water to occupy. What is it? It's a ratio. It's a ratio expressed in percentage of what? Free space in a compartment, free space or free volume, whatever you want to say, divided by the total volume of the space. This free space or the volume is the space which is not occupied by cargo. It is available for the water to occupy. So if I say, suppose a compartment has a total volume of 1000 cubic meters. A compartment has a total volume of 1000 cubic meters. If I say its permeability is 70%, that means 70% of the volume is available for the water to occupy. That means 700 cubic meters of water can come into that compartment. Only 300 cubic meters is occupied by the cargo. If the permeability is 40%, that means 40% of the cubic meters is occupied by the cargo. So is the meaning of permeability clear, beta? Permeability is the ratio.
सर अभी आवाज चली गई थी 10 सेकंड के लिए.
Guys, is that the case with everybody?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Okay. Is it back? Where did you lose me last? What did you hear?
The meaning of permeability.
Okay, this formula you could see, is it?
Yes, sir.
Ratio in percentage of the free space or the volume divided by total volume of the compartment, right, guys?
Right, sir.
Then I was trying to explain this through an example. I was saying that suppose there is a cargo space whose total volume is 1000 cubic meters. And if you say permeability is 40%, that means 40% of this volume is free for the water to occupy. That means 400 cubic meters of water can come in. 600 cubic meters is occupied by cargo. That is what permeability means. Is that clear, beta?
Yes, sir.
Okay, guys, permeability is clear. Permeability is the percentage of, it represents the free space or free volume which is not occupied by cargo where the water can come in, right?
Right.
Clear? Okay, now I'll take one more question on permeability and then we'll call it off and then we can continue tomorrow, no issues. This is a MMD question. Which month? I have not written, but it's definitely a MMD question. A box-shaped vessel 40 meter long, 20 meter wide and 5 meter deep. Okay guys, before I go to this question. Now, if my earlier two questions, the compartment was empty. What is the permeability of an empty compartment as per you?
100%.
100%. Very good.
100%.
So it's not that we did not factor permeability there. We did not speak it out, but it was fully, there was a permeability there also. It was 1 or 100%, whatever you want to say. Okay. A box-shaped vessel, 40 meter long, 20 meter wide, 5 meter deep, is floating in dock water of RD 1.005 with drafts 3 meters, kg 4.2. So let me make the vessel here. Length 40 meters, breadth 20 meters, draft 3 meters, 5 meter deep. Okay. WL, draft 3 meters. Okay. It has a midship compartment 15 meter long, extending from side to side. That means length is 15 meters, breadth is 20 meters. Why it is saying side to side? With permeability of 80%, guys. And now when there is a permeability in the question, I suggest we do like this in the compartment. This will keep reminding us that there is some cargo in the compartment. And permeability, 80% or 0.8, whatever you want to write, because 80 upon 100 is 0.8, right? Is bilged. Calculate the GM after bilging. After bilging, right? Now, obviously, first, we will shade the lost buoyancy. How much will it be lost? Will it be completely? No, that we'll see when it comes to. We will be losing buoyancy in this part of the vessel. This will cause the vessel to sink to a new water line, W1, L1, and we attain a new draft, D1. Now, water will rise in this part wherever the space is. You see, these small things, if you keep in mind, you will not have any problems. Water will come here. This will help you in making the water plane better. Now, if I imagine the vessel to be cut at water line W1, L1, the water plane will be, whole water plane will be a rectangle of length 40 meters, breadth 20 meters. I'll be able to see these bulkheads. And when you cut here, what will you see? You will see some patches of cargo at the water line, and in between the cargo, you will have the water. So that means you will have this loss of water plane taking place here. Length is 15 meters, breadth is 20 meters. Do you agree with these diagrams? Or if anybody has any questions, please let me know. Because if you have a problem with the diagram, you'll have a problem with the question always.
I agree, sir.
Guys, any questions on the two diagrams that I have made? They will hold the key to every question that you do. Done? Okay. Now.
Yes, sir.
Okay, guys. Now, first we find sinkage. Now pay attention. If my compartment was fully empty, then the lost buoyancy would be LBD. Do you agree this would be the lost buoyancy if the compartment was fully empty? Yes or no? Correct? Yes or no? Now the compartment has permeability of 0.8. So that means only 80% of this volume is available for the water to occupy. Full volume is not lost. So how much can be lost? Only that much of it that is allowed by the permeability. Correct, bete? Correct, guys? Lost buoyancy will be LBD into P. In earlier question, P was 1, so it became LBD in all the earlier questions that you did, right? Guys, please let me know if you have understood this.
Yes, sir.
Yes, sir. Understood.
Okay. Divided by intact water plane. My eye goes onto the lower diagram. Whole water plane. This is how I tell myself. Whole water plane L into B minus lost water plane. I look at the lost water plane. If there was no cargo, the entire water plane in the middle would have been lost out. Midships would have lost out. But now cargoes, the surface of the cargo, the area of the cargo at the water line belongs to the ship. The remaining is lost. So LB into P. Now we just put the values. Small l is 15, P is 20, D was 3, permeability is 0.8 divided by 100 into, sorry, I'm taking the old vessel. Length is 40 into 20 minus small l is 15 into 20 into permeability 0.8. How much is the sinkage that we are getting, guys? And please review more than calculations, review the steps. If you have any doubts, let me know.
$1.286.
1.286. Anybody else who wants to validate it? I don't know. I'll get to know only when the final answer comes.
Same, sir. Same. 1.286.
Okay. Guys, any questions on the sinkage part? We have the lost buoyancy has reduced in the same proportion as the permeability, and also the lost area has also been accordingly adjusted LBP. Okay. Now in this case, tell me guys, will KB be D1 by 2 or not? So D1 will be equal to 3 meters plus 1.286 will be equal to 4.286 meters. 4.286. Tell me, will KB be D1 by 2, yes or no? Imagine it to be cut at different levels and see if the water plane is going to be same. If the water plane is going to be same?
Yes, sir. Yes, sir. It will be
divided. So what will I write? I'll write like this, just for the sake of good order. As the water plane in bilged condition is identical from keel to final water line W1 L1, KB final will be equal to D1 by 2 equals to 4.286 by 2, 2.143 meters. Is that clear, beta? You can just cut short then. Anybody who has any questions on KB? If you calculate by moments, you'll still get the same. So why waste time? Now we come to the PM part of it, beta. Now you tell me, guys, I'm asking you just to test you. Look at the water plane area. How many areas are intact in this? All. One is at the forward end, forward side of midship. Other is at the, how many more other than the forward side of it?
So the aft side.
Aft side, any more area which is intact?
The permeable.
The area of the cargo at the waterline. Yes or no? Yes or no, guys?
Yes.
Yes, sir.
You see, this is why we said whole minus lost is a better way. Because if I was adding the areas, intact areas, now they'll become 3. Instead of 1, they'll 2, they'll now become 3. But whole minus lost will still remain the same. Okay. So now, guys, where do you think will be the center of flotation in this case? Look at the water plane diagram. Where will be the geometric center of intact water plane? There are 3 intact water plane areas. Where will be the geometric center of all of them combined?
In the center line.
On the center line, okay. It would be exactly here. Yes or no, beta?
Yes.
Correct. Why? Because for this area it will be here. For this area it will be here. For this cargo area it will be here. The combined geometric center will be here. So this will be the center of flotation. And I draw a 4.5x line that coincides with the center line. Agreed. Now BM will be equal to ICL of the intact, what you write like this, beta, what I'm writing now, upon V. This will be equal to ICL of the whole water plane minus ICL of the lost water plane divided by V. Next, I put in the notational form. For the whole area, it will be LB cubed by 12. For the lost water plane, if there was no cargo, it shall be LB cubed by 12. But if the area has been reduced, the moment of inertia will reduce. If the area was becoming half in earlier questions, it was becoming half. So here it will also become reduced in the same proportion as the permeability, divided by volume of displacement LBD. And we put the values. Length is 40, breadth is 20 cube by 12 minus 15 into 20 cube by 12 into permeability of 0.8 divided by 40 into 20 into 3, and you will get the BM. And then we get the GM equal to AB 2.143. BM you are going to give me minus kg given in the question 4.2. This should give us an answer of 5.721 meters. How much is the BM coming, beta?
So 5.721, yes.
5.7?
7.721
is the GM. That is the answer, right?
Yes, sir.
Yeah, that is
GM,
the
yes,
answer.
sir. GM is,
What is the BM coming?
BM is 7.778.
778, okay. So plus 7.778 here. And that gives you 5.721. Right. Okay. Any questions, guys, with permeability coming in? It does not change anything drastically. And you see, this is a MMD question. So this should now start instilling confidence ki, yeah, we are doing the MMD questions and we are good to actually take them on. If they are from the scope that is already covered. If it lies outside the scope, which is yet to be covered, then of course we'll cover in due course. Guys, I'll stop here for the day. what you need to do is you need to do this question. I have given the intermediate answers, I have given the sinkage, I have given KB, I have given BM. And those of you who can get this question correctly, that means they have understood what has been done today.